Hey guys, welcome back. Now in this video, we are going to cover 4 of the most common indices questions that you will need to know when it comes to solving indices questions. So let us recap some basics before we get into the common questions. So the first rule you have to know is when it comes to multiplying two numbers with the same base, okay, you have to add up the power. Okay, you have to add up the power. So it can be written as multiply here. Sometimes it can also be written as dot. Okay, same thing. When it's dot, it is also multiply. Okay, next it can also be written as this format. It's the same thing. When you see a bracket, it means you're going to multiply. So you have to add the power. Okay, so let's see some example. So multiply, so you have to add up these two, so you get 3 power 8. And next here is there is negative here, so that means 7 plus negative 3, so you get 5 power 4. Okay, next rule, when you see divide, okay, when you see divide or when you see a fraction, it's the same meaning. That means you're going to divide. So when you're going to divide, you have to subtract the power. Okay, subtract the power. So in this case, you get 3 power 1. And the question B, so this one is double minus. Okay, because why? You got divide here, so that means it's 7 minus, and then here negative 3, so negative 3, so it becomes plus, so you get your answer 5 power 10. Alright, the third rule. So the third rule is not the same as the first rule just now. The first rule was like this, right? I showed you all one similar to this, correct? You can see that they have 2 of the same base, so that's why you can multiply them. But this one, the power n here, there is no a. Okay, there is no, it's not the same base, so you cannot multiply. You cannot add the power. Okay, you have to multiply the power. Clear? So you get a power mn. So here is same thing, 7 power, so 4 times 3, you get 12. Next, now when you see that there's a bracket and then there are many values in there, okay, and then the power is outside, you have to power all of the numbers or all of the variables individually. Okay, keyword is individually. So you get a power n, b power n. Same thing applies to division. Make sure you power both of the numbers or the variables in the bracket. Okay, it's not just separately. So here you see here, this is actually the same as writing it like this. It's the same thing. Okay, it's just that here they wrote a multiply. So what do you get? You get x power 3, y power 3. Okay, sometimes it can also be like this. For example, 3x square. I notice some students, they make the mistake of they only square one of the variable only, so you get 3x square. So this is wrong. This is wrong. You have to square both, because the square is for both of them, because 3x is in the bracket, so it's for both of them. So you should get 9x square. Okay, next, when it's divide, same thing, you get x power 3 over y power 3. Next, now what if you see there is a negative 1? Now the power is negative 1. Negative 1 means it's actually very easy. You see, whenever there is a negative power, right, you just bring the whatever value it is, bring it to the bottom. That's it. So for example, let's say you got 3 power negative 2, for example. Then the original number is actually 3 square, but now because there's a negative, so you bring the 3 square to the bottom. It becomes the denominator. Okay, it's that simple. So let's go through some examples. So 103 power negative 2, you get 1 over 103 square. Okay, the negative just brings it down. Okay, next, negative 7 power negative 3. So the negative is not gonna do anything, because I mean it doesn't make any difference, right? If I write like this, for example, if I write Okay, let's say I write like this. So the answer for this is negative 1 over 7 power 3. Now whether I write like this or whether I write like this or whether I write like this is still the same thing. Okay, so it doesn't really matter, the negative in front there. But why we didn't should we do for this as well, right? Because there's a negative here, right? So you have to negative cube this negative. Well, you don't have to, because this negative cube is only for the 7, unless they do it like this, then you have to cube. But of course, for in this case, the answer is still the same. Okay, no difference. So next, now what if it is already a fraction? Now if it's already a fraction, then you just flip the fraction. So you get 4 over 1 power. So negative 5 now becomes 5 because the negative you already flip the fraction. So you can actually just write it as 4 power 5. Okay, same thing here. So the negative, you're going to flip it. So 7 over 3. And then you're going to square it. Okay, the negative square, negative 2 becomes positive now because you already flipped the fraction. Clear? Okay, last rule that you have to know for indices is when you have a fraction as the power, the index. Okay, the power is a fraction. So what does that mean? Now, you just have to remember the top value is the power and the bottom value is the root. Okay, so that means if let's say I write here 3 power 2 over 3. Okay, let me change it. Instead of, let me just write as 5. Okay, so 5 power 2 over 3, you can do 5 square because the number on top here is power, right? So 5 square, and then the 3 here is root, so it's cube root. Clear? So it doesn't really matter whether you write cube root first, cube root 5, then only square, or you write square first, then only cube root. It doesn't really matter. You get the same answer. Okay? So let us go through the example here. So 64 power 1 over 3. So that means is the 1 is power, right? So power 1 is the same thing. So you don't have to write. So you just write the 3. So it's cube root. The 3 is cube root. So you get 4. Answer is 4. Next, 16 power 3 over 2. So like I said, 3 over 2 is, the 3 is the power, the 2 is the root. So of course you can write like this. I said it doesn't matter, right? The sequence doesn't matter. You can do this, but it will be easier if you square root first, because we know square root 16 is 4, right? So we can actually do the square root first. It will be easier than doing this. Okay, so you get 4 cube. Answer is 64. Clear? Alright, last one. So now you have negative and fraction involved. So we do the negative first. First we remove the negative. When you remove the negative, this fraction here you have to flip it. So when you flip, it becomes 64 power 27. And then now the power, there's no longer any negative sign. So it becomes 2 over 3. Okay. So now, same thing. Are we going to square first or are we going to cube root first? Because top here is power, bottom is the root, right? I said. So 2 is square and then cube root. So which one we want to do first? It is easier if we do the cube root first. Okay, cube root will be easier. So we do cube root 64 over 27. After that, we square it. Okay, so when you cube root 64, you get 4. Cube root 27, you get 3. And then you square it. So you get 16 over 9. Okay, so that's how you, this is the basics that you have to know. So now let us go through the 4 most common type of indices question that you will need to know. So the first type of indices question, the first type you will see is when you can turn it into equal base. Okay, equal base means you make it become the same base. So in this case, you see question 1. We can change this and this into 3, right? Because we know 3 power 3 is 27 and 3 power, okay, I write like this. I write the box here. 3 power 4 is 81. But then the 81 is for, the 3 power 4 is only for 81. So you still got the 3x outside there. So you write the 3x here. Equals to 1. So now you can combine. So now what do you do with this? So the property just now I showed you all, you just multiply them, right? So 3 power 3, and then here becomes 3 power 12x. So now what do you do? Because both of them have base 3, so you cannot multiply them, you have to add the power. So what you get is 3 power 3 plus 12x equals to 1. So how do we solve this? Of course we can do one method is doing log method, but I'm not going to do that, okay? Because why? We can change this to base 3 as well. How? If you see the number 1, always remember that you can change it to the base that you like. So in this case, since I'm looking for base 3, I can change this to 3 power 0. Anything power 0 will always be 1. Okay, so if let's say this instead of 3, right, if let's say here the number is 12, then this 1 I'll change to 12 power 0. The key thing is I want to make it become the same base. So in this case, I'll change it to 3 power 0. So here 3 plus 12x. So now since they are both the same base, you can just equate these two power. Okay, so you get 3 plus 12x equals to 0. So 12x equals to negative 3, and x is equals to negative 1 over 4. Okay, I simplified for you all. Alright, now let's see a harder question. How do you solve this? Now same thing, 4 can change to base 2, right? That's the simplest form. 16 can also change to base 2. So we're going to do that. So we get square root. Square root, what can we do with the square root? We can change it to power, right? So it becomes, so I write like this. So I write here 16x plus 2. So now because it's square root, you write 1 over 2. Because remember I said 2, the number at the bottom is root. The number on top is power. So 1, it doesn't matter. So you only care about the 2 there, which is square root. Okay. So now, what do you do with the two of them? You're going to multiply. So when you multiply, you get 16. Okay, maybe I write here. 16 power x over 2 plus 1. Okay, so this is the this is what you get, right? So now we are going to change all of them into base 2. So you change to base 2, you get 2 power 4. Okay, 2 power 4 is 16, right? And don't forget you still have this, so you have to write down x over 2 plus 1, okay, equals to 1 over, so now here 4 power x you can change to 2 power 2, right? And then you multiply with the x here. So actually you don't want to write this again, you straight away write 2x. Okay, so the dot here is multiplier, 2 power x plus 1. So now we're going to expand this, so we get 2 power, so this one you expand, you get 2x plus 4, okay, equals to, so this one you can also combine, so you get 2 power 2x plus x plus 1, right? Because multiply means you have to add them together. So now what we can do is, you see here is in the denominator, right? So what we can do is we can bring it to the top, right? So when you bring it to the top, we change it into negative. So let me write this. So you get 2 power negative, so here is 3x plus 1. Okay, negative. Why is that negative? Because remember I told you all, when for example a power negative 5, the negative will change it into a fraction. Okay, so since this is already a fraction, I can bring the 2 up, okay, and then I just add a negative at the power there. Clear? Right, let me erase this. Okay, let us continue. So now both have the same base, so you can just equate these two the power, okay, the two indices, sorry. So you get 2x plus 4 equals to negative 3x negative 1. Okay, so we rearrange this, you get 2x plus 3x equals to negative 1 minus 4. So you get 5x equals to negative 5. X equals to negative 1. So you got your answer. So we have already done with the first type. Now we're going to go into the second type. So the second type is unequal base. So the first one is equal base. Now the second one is unequal base. What does that mean? Now you see here, this is 2 power x, and then here is equals to 3. Now the first type of question just now, you can change them become the same base, right? Equal base. But in this case, how are you going to make it the same? 2 and 3, you can't make it become the same base. So you have to use log. So this one is a little bit difficult if you don't know the basic of log. Okay, so what we're going to do is we're going to do this. We're going to add log both sides. Okay, we add log base 10. Okay, and then this one is log base 10, and then log 3. Okay, base 10. So what we're going to do is, when it comes to log, the power here, right, we can bring it to the front. So you get 2 log, x log 2 equals to log 3. So this one, the relationship now becomes multiply, right? So what you can do is we can bring this across. So you get x equals to log 3 over log 2. Okay, you can do this. Now, some of you guys who are stronger with the basic of log, you will straight away do this. You can straight away do this, huh? So you see here. Okay, let me write down here. You can see a 2 power x equals to 3, right? So what you can do is, you can straight away take this 2 and shift over. So you get x equals to log 3 base 2. So now the base is 2. So all this while, this one, the first method here, all is base 10, base 10, base 10, okay? Everything base 10. Okay? But if you do it this way, this second method here, you can straight away shift, but the base of the log is log base 2, because you're shifting the 2, okay? So this is one way you can, two different ways like you can try. Okay, so in the end, you will get the same answer. Both of these will give you the same answer, and the answer is 1.585. So I did this for you guys. You can give it a try. Okay, so 2 of it, you get the same answer. Now, let's try a harder one. So you got 5. Okay, so this whole thing, how are you going to make it the same base? Also can't, right? So same thing, what we're going to do is, we're going to add a log. Okay, so we add log 5 power x minus 1 multiply 3x plus 2. Okay, I put a bracket here. Now, if you put log on left, you have to put log on the right as well. So, now what do we do? So, if you don't know, this is one of the properties of log. When you have log, for example, xy, when you see this is multiplying, right, you can break it into plus. Okay, when you see both of these multiplying, you can break them apart to become plus. Okay, then you add log for each of them, x and y. So the same thing applies here. Since this one is multiplying together, you can break them apart to make it become plus. So it looks like this: log 5 power x minus 1 plus log 3x plus 2 equals to, so log 10 is actually what? Log 10 is 1. Okay, so you can just key in your calculator, log 10 is 1. So now, what do you do? Same as the first part just now, this one you can bring it to the front. So you get x minus 1 log 5 plus x plus 2 log 3 equals to 1. Okay, so now since it's multiplying, you can expand the bracket. Okay, expand the bracket. So what you will get is x log 5 minus 1. So 1 log 5 is the same as log 5 lah. No need to write 1. Log 5 plus x log 3 plus 2 log 3 equals to 1. So from here we can see that only this and this have got x inside. The rest there's no x. Okay, so we assume it's a constant. So the other ones we bring it to the other side. Okay, we only leave the x together. So you have x log 5 plus x log 3 equals to 1. So now this one I bring it across, it becomes plus log 5 minus minus 2 log 3. Okay, so now what do? You got the x here, right? So you can factorize the x out. Okay, so you factorize, what you have is log 5 plus log 3 equals to 1 plus log 5 minus 2 log 3. Okay, so now we can find the x value. X equals to, so you write back this one. So since you're going to shift this across, it becomes divide. So log 5 plus log 3. So you just straight away key this into your calculator and you will get your answer is 0.6332. Okay, so the main thing for type 2 is it is unequal base, so you have to add log inside. Okay, when you add log inside, now you need to be familiar with the properties of log. Okay, otherwise it will be difficult for you. So when you understand, you know that you can shift the power to the front. Okay, for log you can shift the power to the front. And second thing is, when it is multiplying like this, you can break it apart into times. Okay, same as divide. If you see there's a divide sign here, instead of a dot or instead of times, it's written as divide, or they write as fraction, you know you can change it to minus. Okay, you can change it to minus here. Okay, alright, so we are done with type 2. Let's go to type 3. So type 3 is substitution, and usually when do you use substitution is when you notice that you can't really apply type 1 and type 2. Okay, when you see that you can't really apply type 1, type 2 into the question, that means there's a high chance it is in type 3. That's the first difference. The second difference is when you notice that the relationship between the numbers are plus and minus. Okay, plus or minus. Okay, because type 1 and type 2, they are usually multiplying each other or dividing each other. Okay, so that's why you can make it become the same base and combine, or you can add log. Okay, but in this case type 3, usually it is plus minus. Okay, but the easy way is, if you notice that you can't apply type 1, type 2, then it's the high chance it is type 3. So let us see how to solve type 3. So same thing, we're going to change it to become the same base first. So 2 power 2 is equals to 4, right? And then you got the x outside here, plus 2 equals to 3 2 power x. Okay, so what you notice here is that you can actually change this. Okay, you change this, it becomes 2 power x times 2, right? It's actually the same thing. So why am I doing this? Because if you notice, I got a 2 power x here, I got another 2 power x here. So what I can do is I can use substitution method. Some of you guys, maybe you can see what I'm trying to do here, but for those who can't, this is what you're going to do. You're going to let 2 power x become another variable. Okay, up to you. What do you want? Let's say I make it become becomes y. Okay, 2 power x becomes y. So now I substitute here, it becomes y square plus 2 equals to 3y. So what do you notice here? I can rearrange this to become a quadratic equation, right? Quadratic. So y square minus 3y plus 2 equals to 0. So now I can factorize. Oops, sorry. I can factorize this. So I get y here, 2, 1. So do I add or subtract? Let's see. So we can do this minus minus. So from here, okay, let me write here, I have no space. Y minus 2 equals to 0. So y is equals to 2, right? But what is y? Please don't leave it as y because you changed the equation, right? So you have to put it back. So you put it back to 2 power x equals to 2. So from here, when it's 2 here, that means it's 2 power 1. So from here we know x is equals to 1. Okay, so that's the first answer. Then you have to do for the second one as well. So let me write here. Y minus 1 equals to 0. So y equals to 1. So y is what? 2 power x, right? Equals to 1. So 1 is what? Remember I told you just now? You can change it to become the same base. So 2 power 0. So that means x is equals to 0. So you got two answers here. Okay. So let me just divide this so that... so yeah, you got two answers. Clear? Now let's see a harder question. So this one, 3 power x plus 1 plus... So if you notice this question, right, you can't really do... sorry, what? The 36 here, you can't really do much, right? So we're just going to leave it. So what we can do is, here got 3x, here got 3 power x, 3 power x, right? Yeah, so what we can do is, we can change it to this. 3 power x multiply 3 power 1. Okay, we write this. Why we can change this? Because, remember, when you multiply, the power you plus, correct? So if you do that, you will get the same thing, the exact same thing. So I'm just splitting the x and the 1. So I split them, becomes times. So plus 3 power x equals to 36. So this one, we can factorize what? We can factorize the 3 power x. Now for those who don't know, then you use the substitution method. Okay, so let's say let 3 power x equals to y. Okay, let's say. So now you get y times this 3 here. So you get 3 plus y equals to 36. Correct? So what are you going to do here? Technically you don't have to factorize. You can just add them together. So you get 4y equals to 36. So y is equals to 36 divided by 4, 9. Yeah. So that is, oh sorry, wait. What am I thinking? We are not done yet because this is y. We cannot change it to y. We have to put it back to the original equation, which is 3 power x. 3 power x equals to 9. 9 is what? 3 square, right? So from here, we know that x is equals to 2. Right? So that's how you use substitution. Now, if you want to do directly from this, okay, right? If you don't want to do substitution, you can, but provided you can see what's going on. Okay, so this one becomes this becomes 4 3 power x equals to 36. So 3 power x equals to 36 divided by 4, you get 9, and then 3 power x equals to 3 square, so x equals to 2. Now if you can see it like this, then good for you lah. You don't have to do this method, substitution. But if you can't, I suggest you do the substitution. Right? Now let's look at type 4. So let us look at type 4. Now type 4 is simultaneous equation. Now when do you use type 4? You normally use type 4 when there are more than one variables involved. Okay, there are more than one unknowns. So for example, you see here, there's x and there's also y. Okay, so when there's x and y, then there's a high chance that you need two equations to solve it. And when you have two equations, you can do simultaneous equation. Okay, so let us solve this together. So same thing, 2 power x times, so I change it, all of this can become base 2, right? So I'm going to change it to base 2. So 2 power 4y, remember, because 4 is equals to what? This 4 here is equals to 2 power 2, right? So 2 power 2, and then there is a 2y here, so I have to multiply, so I get 4y. Okay, equals to 2 power 3. So what you can do is you can combine all of them, because they are all the same base. Okay, so it becomes 2 power x plus 4y equals to 2 power 3. So now that they are the same base, both sides, you can just combine them. So x plus 4, y equals to 3. So this is your first equation. Okay, first equation. Now we have to find the second equation. So this one we can do cross multiply. We cross multiply, we get actually you don't have to cross multiply lah. You can just bring this over. So it becomes 3x times 27 over 9 power y equals to 1. Okay, so this one all I can change to base 3. So 3 power x times 3 power 3 over 9 is equals to 3 square, right? So 3 square will be 3 power 2y lah, because you got the y here, equals to 1. So I can change this to become 3 power x. Now you see, times means you have to add the power, so x plus 3, and then since this is a fraction, right, so you're going to divide. So when it's divide, you have to minus the power, so it becomes minus 2y equals to, so 1 I can change it to the same base as this, so it becomes 3 power 0. So they are the same base already, so I just write 3 plus x plus 3 minus 2y equals to 0. So I rearrange this, x minus 2y equals to negative 3. So you got your second equation here. So now you can do simultaneous. Okay, so equation 1 and equation 2, how are we going to do simultaneous? Let's say we use elimination method and we eliminate the x. Okay, we eliminate the x, so you have to subtract, okay, minus the two of them. So you will get x minus x, no more, 4y minus negative 2y, so you get 6y equals to, now 3 minus negative 3, so you get 6. So from here you know y is equals to 1. Now we have to find x, so we just substitute into one of this equation. So we get, there right here, I do this, x equals to negative 3 plus 2y, so y is 1. So negative 3 plus 2, you get negative 1. So x is negative 1. Okay, so this is how we do simultaneous. So these are the 4 types that in my opinion are the most common, which you will encounter when it comes to indices. So if you find this helpful, don't forget to like and subscribe, and I'll see you on my next video. Take care. Bye bye.